In this video, I am going to solve problem 4 from chapter 16, Waves 1 from Principles of Physics, 10th edition. The equation of a transverse wave on a string is given by the equation y equal to 2 millimeter sine of 15 per meter x minus 900 per second t. The linear density of a string is 4.17 gram per meter. What is the wave speed? What is the tension in the string? So here the wave equation on the string is given, and the string linear density is given as 4.17 gram per meter. By using these, we are going to find the speed of the wave on a string as well as what is the tension produced in the string. So for this, what I am going to do, first of all, I am going to write what is given, then we are just going to solve one by one. Clear? Okay. And before that, we must know what is the formula for the speed. So let's write what is the formula for the speed. In the theory, we studied the formula for the speed of the wave on a string is given by the rule v, which is equal to square root of t over mu, right? Okay. Now in this equation, first we are going to find what should be the speed. In the second question, we are going to find the tension. So for finding the tension, it's very easy. I'm going to use the same rule, but I have to squaring on both sides to discard the square root, right? So if you square, what will happen? The left hand side of the equation becomes v square, right hand side becomes t over mu, right? And if you rearrange this equation in terms of tension, you will get the answer for the tension, right? Okay, tension T, which is equal to v square multiplied by the linear density. And the linear density value is given here. Mu equal to 4.17 gram per meter. If you convert it to kilogram per meter, you have to multiply by 10 to the power of minus 3. So 4.17 becomes 4.17 multiplied by 10 power minus 3 kilogram per meter, right? Okay. Now, better I can write the equation. What is given in the equation? Y equal to 2 millimeter sine of 15 per meter multiplied by x minus 900 per second t square. The bracket is closed. Am I right? Okay. For this, what I'm going to do, I'm going to write the general equation to identify it. So what is our general equation for the wave equation? Y equal to y of m sine of kx minus omega t, right? Now the k will have the value. I'm going to compare the k with the equation. So the angular wave number k is equal to 15 as they mentioned in the question, right? So the angular frequency value is exactly equal to 900. Now what I'm going to do, I'm going to solve the first question very easily, because in the theory we studied the relations between the speed with respect to the angular frequency and the angular wave number. Am I right? So what is the rule that? So we studied in the theory the speed which is given by the equation of angular frequency divided by the angular wave number. By using this, we can easily find the value of the speed, right? And the angular wave number, which is 15, and the angular frequency, which is 900, by using, we can easily find the answer for the first question, right? So let's start. First question, we are going to find the speed by using this equation v equal to omega over k. Here in this equation, our omega is exactly equal to 900 and the angular wave number k is equal to 15. So omega 900 over 15. Let's see what is the answer for the speed of the wave. 900 over 15, I got the answer exactly as 60 meter per second. So this is the answer for the first question. So v equal to 60 meter per second, right? Okay. Now by using the speed, I'm going to find the answer for the second question. In the question they mentioned you have to find the tension, right? So for finding the tension, I'm going to use the equation from the speed. As I already explained earlier, we know V, which is equal to square root of T over mu. If you're squaring on both sides, this becomes V square, which is equal to T over mu, and therefore T is equal to mu multiplied by V square. So I'm going to write mu multiplied by V square, and I'm going to take this V, I'm going to substitute here. And the linear density value already given as 4.17 gram per meter. So I have to convert it to kilogram over meter, right? So I'm going to use this data here. So T equal to, our linear density value is 4.17, right? So 4.17 multiplied by 10 power minus 3 multiplied by 60 square. Let's see what is the answer for the tension. So 4.17 10 power minus 3 multiplied by 60 square, I got 15.01. 15.01, and its unit is Newton. Clear? So this is the answer for the second part. Clear? So this question is very easy. The most important thing, you have to compare the general wave equation with the equation given in the question. And from the equation, from the general equations, you have to find some parameters, right? And also in the second part, we have to find the tension. So we already studied all these formula in the theory. So please use it properly. Clear? That's it. Thank you.